In this problem, we're given a function represented as an equation, a table of values, and a graph, and we're to find the domain of the function and write the domain in interval notation. I want to start by using the table of values and the graph as a guide to show you why it seems like the domain of my function would be all real numbers except for 3. It's helpful to think of the domain as any input, in this case x, for which if you were to substitute that x value into the equation, it would be possible to calculate the output, and that output would be a real number. So to quickly define what it means for a number to be in the domain, consider x equals 4. If you were to replace x with 4, we would get that the function value when x is 4 is 1 over 4 subtract 3, and because I can calculate 4 minus 3, it's 1. We would have 1 divided by 1 or 1, and the fact that that came out to be a real number output, x equals 4 is in the domain of my function. In the table of values, it says if you replace x with 4, the output comes out to be 1. On the graph, if you were to go to x equals 4 and up to this point here, you would see when x is 4, the output, or labeled as y in this example, would be 1. So the graph and the table of values both have the information that x equals 4 is in the domain because it corresponds to a real valued output, in this case the number 1. It turns out the only x value that creates any issues for this problem happens to be the value x equals 3. Whenever you have a variable in the denominator of an equation, you must worry about the denominator of the fraction becoming 0. In mathematics, division by 0 is not defined. So notice when x is 3, the table of values say that the output of the function is undefined. Also, on the graph, when x is 3, there seems to be no corresponding y value. I look up and it doesn't seem like I can quite hit the curve. This is because when x is 3, there is no y value. If I was to replace x with 3, you'd see why there's no output. Replacing this x with 3 and this x with 3, notice my denominator would be 3 minus 3 or 0. So when I go to calculate the function value when x is 3, it involves calculating 1 divided by 0, and division by 0 is not defined in mathematics. So this would be the only x value that we need to exclude out of the domain. So the domain would be all real numbers except x equals 3. This is an acceptable way to express the domain. However, this problem wants us to express the domain in interval notation. So if you were to look at a real number line, here's a very crude real number line, how would you express that you want to represent all x values on the entire real number line that goes to the left forever, meaning x values going in the direction of negative infinity, and to the right forever, meaning x values going to positive infinity, except 3. So on a real number line, we put a circle here to indicate that 3 is not included, but every other number is. This is a graphical representation of saying all real numbers except 3. It will help me explain the interval notation. In interval notation, we choose the number that's the least first. That would be negative infinity. We write a parenthesis or bracket to indicate whether you actually include that number. Negative infinity is not a real number. We never include it, so I'm going to put a parenthesis. Then you put a comma, and then you see how large the x value can get before you have to stop. And our interval includes all numbers up to 3, but not including 3, so I'll put a parenthesis. But now I need to write another interval to represent all numbers bigger than 3. But remember, 3 is not included, so to express this interval here, 3 would be my smallest number. I'll write a comma, and since it includes all possible numbers to the right forever towards positive infinity, I'll write infinity. Infinity is not a real number. We never actually include infinity, hence the parenthesis. The 3 shouldn't be included. Remember, we excluded x equals 3 in the domain, so that deserves a parenthesis. And whenever we put two different intervals together, we put a union symbol, which is basically a symbol that looks like a capital letter U. In fact, if you're typing this into a computer, it is likely that the syntax that you are to use would be the capital letter U on your keyboard. This was a very useful example to explain the meaning behind the domain. It is interesting to note, however, that finding the domain in this situation usually entails identifying the denominator of the equation, and a more straightforward approach would just say, I wonder what x values would make my denominator 0. So when would my denominator, in this case x minus 3, be 0? You'd solve that equation by adding 3 to both sides, and you'd notice that x equals 3 is the input that would have you dividing by 0, and then if you understood what domain means, you'd know that's the x value that creates this issue here of division by 0, and you'd know that's the only one you need to exclude.